Hello, everybody. In part two, I will discuss with Dr. Al-Nasir Abdelwahab several topics about physics, as we have already discussed in part one, the difference between science and pseudoscience. Welcome back, sir, and you can show your slides and you can start.
Let's start from the place where we stopped.
Yeah.
So, you have to.
I have to enable. Yeah. Sorry.
Enable me, yeah.
Yeah, go ahead.
Okay.
Yeah. Last time we stopped here at
Yes.
the slide of Colombo. Yeah.
Yes, exactly. So, what maybe resuming, we didn't take much last time. It was a little.
Brief introduction. Yeah.
It was actually a lengthy introduction, but it was necessary. So we spoke about the difference between science and pseudoscience, and we said the most important thing in this demarcation is that we should have a body of evidence, and then we'll generalize from this body of evidence some rules, and then we should, and these rules we may call theorems if we like, or theories, and then we should have a falsification procedure. That is, if I form a theory, of course, I'm speaking here of natural sciences. In natural sciences, when you form a theory, you need to have an experiment or something similar to falsify it. We said that as per Karl Popper, there is nothing called verification of a theory. What we do is only an attempt of falsification, not verification. So we took this working example now, and it was, we imagined Colombo, the detective, finding someone who was killed, actually. Let me go back to the original. Yes, here. So a man is stabbed, and there are footprints of a man near to the body. And although the man had a lot of money on him, nothing was stolen. Now, this is an important clue, because evidently it's very difficult to have hypothesis C where a complete stranger killed him. I mean, if a complete stranger would have killed this guy, then at least he should have taken the money. But to kill someone without taking even the money and having any connection to him, this is insane. It's not conceivable. So if we form here, Colombo has here three hypotheses, possible hypotheses. A male acquaintance of the victim killed him, someone who knew the victim killed him, a female acquaintance of the victim killed him, and a complete stranger killed him. So the question, I pose the question to you actually, which one is scientific, which hypothesis is scientific, and why? Especially if we think about the falsification. So what do you think?
I think we did this trial in the first part, and I said
the first part,
yeah.
The first part is scientific because it is coherent with evidence. It's not inconsistent with the evidence, because we find footprints of a man, and it can be falsified by checking solid alibis of male friends. Yeah. So Colombo will get all the male friends and check whether they were near to the scene of crime, or whether whether they were not near to the scene of crime. So that this is called an alibi. Alibi means that I was somewhere else.
The evidence of absence. Yeah.
Yes, exactly. So A is scientific. What about B? What do you think?
Yeah, it cannot be proven that his female acquaintance. Yeah, it's very difficult.
Is it the question is it a scientific hypothesis or not? So can I check it? Can I falsify it? How can I falsify B?
To prove that a female that it was
No,
at
to
the scene
falsify. How can I falsify that a female acquaintance of the victim killed him?
to show that the footsteps of a man, not of a woman, maybe.
Yeah, but she could have deliberately put the footprint of a man. So this is not really. It is evidence or
This is
negative
a
evidence.
cogent one, a cogent. Yeah.
So actually B is also scientific, but it is incoherent with evidence, and it can be falsified also by checking the solid
And
alibis
it's a
of female friends. So again, Colombo will take all female friends and investigate them and be sure whether they have alibis or not. But hypothesis B is needs a little more effort because the footprints of a man contradicted. So hypothesis A is coherent. There is no contradiction. It is nearer to believe than hypothesis B. But hypothesis B is still scientific.
Still a possibility. There's a
It is
possibility.
still a possibility. Exactly, it is still a possibility because she could have used the footprint of a man to frame someone. What about C? What do you think about C? A complete stranger killed him. How can I falsify C?
By checking the cameras.
Yeah, no, now this is a very genuine and very important question. How can I falsify C? Can I falsify C? Can I falsify all complete strangers of a man?
That's difficult.
Can I check all alibis
And
of
what's
everybody?
yeah, it depends our knowledge about these persons and his acquaintances as well. Is it a foreign person?
No, even suppose that he has only a small number or a big number of acquaintances. C says that a complete stranger killed him, and this complete stranger has no money motive also. He didn't take the money from him. So actually, C is pseudoscientific. Why? Because complete stranger who killed without motive cannot be falsified. You cannot falsify this claim. If someone came to Colombo and he told him, "What about a complete stranger killing him?" He would laugh at him because there is if this happens, this will be the perfect crime. This will be the perfect crime. Actually, the perfect crime is I mean the perfect murder is to kill someone without motive and whom you don't know. So you just go and kill anyone on the street whom you don't know and you don't have a motive. So there is no way to falsify this claim. So this claim is actually pseudoscientific. Why? Because we don't have a method to falsify. We cannot take all the persons in the city and check their alibis. Yeah?
It's impossible.
Because millions, you cannot check millions of people's alibis. Yeah,
yes,
so it is not falsifiable.
Yeah.
It is impossible. So it is impossible to falsify. It might have happened. There might be some lunatic who kills just like this.
Yeah.
But it will not be possible to pursue this hypothesis. This hypothesis is impossible. It's not scientific. Yeah, and this tells us about science. Actually, if you don't have a way of falsification, if you don't have a clue how to start going behind the question, then not even science can help you. Yeah. So you cannot check alibis of all complete strangers to this man. Yeah? So here we have three possible hypotheses. A and B are scientific, but B is less
Probable.
probable than A.
Mm.
A is more probable, and still Colombo has to dig a lot more to be sure of the alibis and all this. Yeah. Now let's go back to the cognition, and maybe I've got here a list of or sample basic cognitive terminology. So what is scientific evidence? Actually, when we say scientific evidence, it's very important before you start any scientific research to know what in your area is scientific evidence. So
it's called what's called the research methodology. Yeah.
No, first, even before the methodology, you need to know what is scientific evidence. It's a term, and it's a notion which should be very clear for you before going into your science area. Otherwise, it is a joke then. If you don't know what exactly constitutes a scientific evidence, then you shouldn't do science. You should do something else. So I'm giving here two examples. In math, of course, always I will be talking about math and physics in this lecture. So in math and in logics, proofs are considered to be scientific evidence. When I say scientific evidence, mathematical scientific evidence, then I actually mean proofs, that I have mathematical proofs. And those proofs are either deductive or inductive. Deductive means using rules of logic, starting from a set of proven axioms and valid assumptions to form conclusions. So those conclusions are called evidence. So I have, for example, there is evidence that Socrates is mortal. Why? If I have the rule, all humans are mortal, and I know Socrates is a human, then Socrates is mortal. I have evidence that Socrates is mortal. Why? Because I have the rule, and I apply the rule using sound inference rules. So this is the inductive way, the deductive way, the way from a general rule to
and this is the core of the Aristotelian logic.
Exactly. This is the core of Aristotelian way of thinking. Now, the inductive way, you have also induction in mathematics, but it must be complete induction. Means you have a set of things and you show for all members of the set of things that some property holds. For example, there is scientific evidence that all even numbers are divisible by 2, of course. You can show it, you can prove it using induction. Induction in this case is complete induction, not when I speak about induction in the context of math and logics, I usually mean complete induction. While in physics, as we discussed before, and in natural sciences, it is incomplete.
Incomplete induction, yeah.
Now, the scientific evidence in math, when I say scientific evidence, I mean proofs, either deductive or inductive. In physics, I have empirical data, and I am doing experiments all my life. So falsification is therefore only possible for finite domains. I cannot falsify. I cannot. When I say falsification, I cannot go and do all possible experiments.
Yeah. For example, we cannot stop the sun and to see what will happen, or to stop the Earth revolving around the sun.
No, we have already discussed this when we spoke about last time about Newton's first law. Newton's first law, the law of inertia, says that if a body is moving in a constant with constant velocity, then it will change its direction when there is force. So actually, how do you falsify this? How do you falsify this? You cannot falsify this because you cannot wait forever until you see whether there is something else which changes the velocity of a body. So you just assume that it will continue like this. Yeah. So in any case, falsification is only possible for finite domains. For example, there is scientific evidence that rays of the sun are more intense around the equator because we can do the experiment. So we can do the experiment. I have empirical data, and this empirical data is not verifying, as we said, but it is an attempt to falsify my theory, and when it works, when there is no problem, then I haven't falsified the theory. That means the theory is still valid. While there is no experiment, so there is no scientific evidence showing that every object will remain at rest in uniform motion in a straight line unless compelled to change its state by the action of an external force. This is what we just said. So while I have scientific evidence that rays of the sun are more intense around the equator because I can do the experiment.
So this is part of Karl-Popper. It's one of the three conditions for Karl-Popper stability.
Yes, the stability, exactly. So while I can do the experiment to say whether see whether the rays of the sun are more intense around the equator or not, I cannot do the experiment which shows that every object will remain at rest unless a force changes. Why? Because to do this experiment, I need not to apply any force on the object and just leave it. And the experiment will have infinite time. I will stay for infinity until I know whether it will change its velocity or direction or its whatever. And this is evidently impossible. So there is no scientific evidence showing that every object will remain at rest. What is there is, now this is a very important question even in the discussion with falsification and demarcation, all this, because while there is no scientific evidence showing that every object will remain, there is actually negative evidence, means that in any experiment where an object has changed its direction, there was a force. So there was always a force when an object changes its direction, which means that it didn't falsify. So every experiment ever done around this idea of inertia did not falsify Newton's first law. So I could not falsify with any experiment Newton's first law. This is why I consider Newton's first law to be a very anchored hypothesis. It is a hypothesis. There is no proof. There is no scientific evidence, but I couldn't falsify it. Now you see that in physics there is a very new concept here. The concept of my incapability to falsify something. So it's not only that I provide positive scientific evidence, but I fail to falsify a certain law. I consider this failure to be in itself a law. And this is the core of the principle of incapability. And actually, this is the most important principle used. Heuristic. It is a heuristic principle, means it is a practical principle. It's of course it's not logical, but it is heuristic. It's not logics here, but heuristic. I did a lot of attempts and a lot of experiments, and in all those experiments, I couldn't go through a certain wall or let us say a certain area. Then I consider this area as a boundary, a legitimate boundary of my model. This is the core of the incapability principle in physics. So,
which denotes the limitations of science and its relativity.
Yes. Of course, no. It's actually the boundary of your model. We said that the models are models in modern science. What you do is you do a model. You model the phenomenon which you are studying.
The paradigm.
You never claim that this is what you are saying is the absolute truth. We are going to see this in the next slide. But here, let us recap here. So while in math, scientific evidence are proofs, in physics, the experiments are the scientific evidence. And these experiments, if they are there, they are actually always an attempt to falsify. And if I cannot falsify a certain rule, then I consider this rule for a good reason, because if I cannot falsify something, of course, you don't create some hypothesis and just do only 2 experiments and they say this is a rule. Yeah, you will do
I can give example from the Muslim tradition. Ibn Mattawi, he was a Mu'tazilite, and he said if two bodies fall together like a feather, a piece of feather, and a ball of iron ball, without air, they will fall together simultaneously together with the same speed. And after he was in the 4th Hijri century, and now I think 10 years ago they did this experiment in the US when they a room evacuated of air, and they did the experiment.
No, but this, you are wrong here, Ahmed, because this experiment was done 100 years ago or something like this. We took this, of course, we took this experiment in school actually, because it has to do also with Newtonian laws. So no, not 10 years ago, but let's say 100 years ago, something like this, they did this experiment.
Because it was in BBC,
yeah, no, so they did this experiment. But what I'm saying here is that physics, for physics, the scientific evidence comes from the experiment. And if we can do these experiments, so if we can do the experiment, we have scientific evidence, which we can, like, for example, if we want to know whether the rays of the sun are more intense around the equator or not, we go there and we test them and we measure them. And so this is a legitimate experiment. And there are some things where you cannot do experiments, but whatever experiment you do to falsify doesn't falsify the rule, like Newton's first law. So we cannot do the experiment just leaving an object forever traveling.
So it can be right or it can be wrong.
So we cannot leave it, but evidently we cannot leave an object flying in space forever or flying on the Earth forever and wait until we see whether without any force it will change its direction. We cannot do this. But what we can do is that to notice that in all our experiments, where an object changes its direction, there is a force. So this means that the Newton's law is valid actually, and it was not falsified and cannot be falsified. Until now, no one falsified Newton's first law. Actually, this is why it became Newton's first law. Yeah. So to recap here again now, to make the terminology a little more precise, types and degrees of evidence. So I have objective or scientific evidence, evidence which you can communicate to others. Yeah. In all ancient and modern sciences, you have some evidence which you can communicate, and this is why it's called objective. Now, you could have also subjective evidence, which you cannot communicate to others. Like, for example, if you are hungry, so you have evidence that you are hungry, you are feeling your hunger, you are really hungry, but how can you communicate this to others? Others will always say, you could also pretend. Yeah. There is no objective way to tell whether you are hungry or not. So the types of evidence are 2 actually, not 1: objective and subjective. Yeah. Now, for the degree of certainty, this is also interesting, and it applies to both of them: the evidence, the subjective, and the scientific evidence or the objective evidence. You have knowledge if you are 100% sure, and E and SE is 100% validated through math. So if I make experiment in a finite domain, for example, I say
E and D stands for
E stands for the subjective evidence, and SE stands for scientific evidence. So I took the S because the S. So E is the subjective evidence, like you are hungry. Yeah? But SE is scientific evidence. And I'm going, of course, to use all the time SE because we are speaking about science. So so if your SE is 100% validated through math or experiment, yeah, then you are speaking about knowledge. Anything else is belief. Yeah? Of course, it has you have to be above 50% sure. So, for example, if you many people don't believe in UFOs, yeah. Why? Because there is no scientific evidence, they tell you. So they don't believe. This means that they might believe a little in some disturbances and some paranormal activities and so on. But it is not enough to make it a belief, means above 50%. Yeah? And it's of course very much different than knowledge. And by the way, this is the distinction, the classical Western distinction of degrees of certainty of evidence, whether subjective or objective. So you have two.
I think this is a Kantian division, yeah?
I don't know, but it's not important. It's actually not enough to, as we are going to see, it's not enough to model and to be used really in science. In summary, you have here 2 times 2 means 4. In summary, you have 4 types of scientific evidence, and math rejected all belief types. So actually, especially somebody like Bertrand Russell, so actually you have objective scientific evidence leading to mathematical knowledge. So this means that you have a proof, objective scientific evidence leading to mathematical knowledge, or objective scientific evidence leading to empirical knowledge. This is what you do induction in physics, because you could do, for example, the following experiment. I want to prove that everybody in this room is taller than 180 centimeters. I can do this. I can measure, and there are, for example, 20 people in the room. So I can have at the end objective scientific evidence, empirical, actually. This is not mathematical because I'm measuring the length, and it is knowledge. I know that everybody in the class is more than 180 centimeters. Yeah. So while here OSE MK is actually, I have a proof, mathematical proof. So I for knowledge, because we just said that knowledge is certainty, about certainty, I can be certain of some mathematical of some knowledge in mathematics by having a proof. I can be certain of my knowledge in empirical domains, in natural sciences, if I have a complete inductive proof, a complete one. Of course, the most is OSE MB and OSE EB, means objective scientific evidence leading to belief in mathematics. So there are some things where I don't have a proof and I don't have a negation in mathematics. We'll come to this, and this causes a problem because usually mathematicians say, no, either we know it or we don't know it. At least this was until the middle of last century. So until this, for example, in the year 1900, in the 1900, they started a big project. David Hilbert started a big project to try to convert every mathematical belief they were having into mathematical knowledge, means to seek proofs for whatever open question was there. Yeah. and until and this remained this project, this very big, very famous project. It's called the project of re-establishing the fundamentals of mathematics around mathematical logics until the results of Gödel and what we are going to speak, and Skolem and so on. So you have objective scientific evidence leading to MB, mathematical belief, or objective scientific evidence leading to empirical belief. Of course, mathematicians refuse this, usually. Nowadays, it's a little bit different. Like mathematicians, they will say either you have a proof or you don't have a proof. This was their classical attitude. Yeah? Most of the natural sciences is around this area, objective scientific evidence leading to empirical belief. So I have empirical belief, for example, that quantum physics is right. I have empirical belief because I'm coming from axioms which have no proof. They are assumptions. They have been done using the incapability principle, but it is still a belief. So it's a belief. Now the question I ask now, is this sufficient to distinguish between the hypothesis A and B, which we had in the working example? Let's go there. So of course, we ruled out hypothesis C, as you know, because it is not scientific. But now the question is, what about A and B? Is it enough to say either I believe or I know? Of course, both of them, I believe. I mean, A is here again, A is scientific because it's coherent with evidence and can be falsified by checking solid alibis of male friends. So now, in case all have alibis, suppose Colombo went and did this experiment. I mean, okay, in that case, this is an experiment, actually. This is what you may call an experiment in criminology, that you go and sit with the people and check their alibis. Yeah? So suppose all have alibis. Now, all male friends of the victim have alibis. Then A is discarded. Yeah? Of course, if they all were definitely somewhere else, they could not have killed him. Yeah. Otherwise, A is objective scientific evidence leading to empirical belief. Otherwise, if someone of them has no solid alibi, then Colombo will suspect him. And actually, if you are really a fan of Colombo, I am a big fan of Colombo. Actually, he has always one guy in his mind from the beginning. So you see the crime, and then Colombo comes and he starts to see some evidence pointing to someone.
So this is a kind of deduction, huh?
No, actually, to the contrary, it is now a kind of empirical induction.
But from the beginning, he has
this is not deduction. No. Of course not.
I misunderstood.
What I meant from the beginning, I meant that after he goes to the crime scene, yeah? When he goes to the crime scene, he has a certain number of evidence there, yeah? Like, for example, the footprints, like all this. And then he makes interviews with the people who are around. And then he starts to suspect someone.
I misunderstood because
this is actually incomplete induction. This is not deduction. He doesn't have a rule. It's not like
I think from the very beginning that he had suspected.
No.
Okay. I misunderstood.
I mean, you should see some of Colombo's series. You find that he will the guy or the lady, the killer, at the end he's always right, and he's trying to get a confession out of them, of the killer. But a number of evidence is there in the beginning. He goes through this evidence.
So this is induction, yeah.
He then makes a certain assumption, and this assumption is not without scientific evidence. There is always scientific evidence. He can always say, for example, I found tobacco which only you will be smoking. Yeah.
Mm-hmm.
When the guy he actually forces the guy to confess with this evidence. He comes to the guy, to the murderer, and tell him, I
Yeah.
found this and find that. Yeah. But from the beginning, he has this in his mind. Before a confession, he is always having OSEEB. So he always has a belief, an empirical belief. He never has knowledge. Colombo doesn't go and say, I know you killed it.
But he
Killed him.
believes that someone between among these people,
Yes.
yeah,
If there are, in case someone does not
like that.
have a solid alibi.
Mm,
If all of them have solid alibi, he discards the hypothesis altogether. Yeah. Now, B is also scientific. This is a female, but it is incoherent with evidence and can be falsified also. So he will get all the female acquaintances and ask them. And in case all have alibis, B is also discarded. But otherwise, B is also, like in the first case, objective scientific evidence leading to empirical belief. So in both cases, he might, therefore, he usually has many hypotheses. But which hypothesis is stronger in that case? Of course, the first one is stronger because it doesn't contradict with the footprints. Yeah. So in case all have alibis are stronger than any other evidence. So if someone can prove to you that he was not in the scene of the crime, then you must discard him. Yeah. Even if you find evidence that he was there, maybe this evidence was put there. Yeah. If he can prove to you that he was someone else, then this evidence was put deliberately. Yeah. So in case all have alibis, the alibis are stronger. In case not all have alibis, hypothesis A is stronger than B because it is coherent with evidence. As you see here, you don't have only either knowledge or belief. Yeah. You need to, within the belief, you have also a scale of beliefs. How strong is your belief? How weak is your belief? Yeah.
There's a middle path between knowledge and belief, and they are interrelated somehow.
No, actually, knowledge is because it is 100%. It's out of question. Actually, if you think about it, I mean, if you are interested in this Colombo series, you will find that he never ends any of his crime investigations without confession. He cannot take the guy to jail without getting a confession of him. So the confession is knowledge. Confession is knowledge.
As we in the first part ended with Columbus, in this second part as well, we end up with
we have to end again.
Yeah, because this is the dedicated time for this part, so we can continue and go on in the third part of our podcast.
Okay.
Thank you, sir, for this. We will leave it here, and we will continue the rest of the these lectures.
Okay. Thank you.
Thank you so much, and this is the end of part 2. And thank you so much, our dear audience.